Alright, so the last and final type of projectile motion. This is the last video for this unit in kinematics with 2 dimensions. Alright, this should be no surprise. Perpendicular vectors, and let's solve problems. Okay, last lesson. Let's remember a few things. Remember the rat example. The rat's going up and down. I said that my x components are independent of the y components. In the x, we're dealing with constant velocity. With y, we have acceleration. So anytime we're dealing with anything x, constant. Anytime we're dealing with y, acceleration. The only thing that transfers is the time. So that's what you can know from last lesson. Let's do a type 3, which looks like this. So we've got Batman standing on top of the building and is throwing a batarang, which is his little bat thingy, at the Joker. He throws it at 12 meters per second, 20 degrees above horizontal. We want to know a few things. First, how long until the batarang hits the Joker's head? We're going to assume the Joker is 2 meters tall, so that will affect something later on. Let's take a look. Just like any projectile motion, we're going to write out this entire, not table of values, but your x and y. Make all these values in here, just so you can spread out your information and see what you got. We know acceleration. We know the dy is negative 33, so it's 33 instead of 35 because the Joker's 2 meters. So it only falls down 33 meters. I told you the 2 meters will be important. With that, we need to break up our initial velocity into components, x and y. Again, anytime your velocity is given at an angle, we need to get what is the x and the y components. So this is using trig. Vy initial is sine, because that's the opposite. Plug in numbers, get the opposite. Cosine, we're going to get the adjacent, which is your Vx. Got to get these two components. That should be very straightforward. And anytime you have a projectile launched at an angle, do this automatically. This, if you do the table and those, that's 3 marks automatically. It's worth just knowing how to do that. That's almost passing the question without even doing anything really special. All right, now that we got that, we can plug numbers into an equation. So this one involves everything that I need, but it doesn't have time. The reason I'm using this is so I can find my final velocity in the y. With that, I can get the time. I'll explain why in a second. So we plugged in some numbers. Don't forget to put negative 9.8 and negative 33. If you don't put those in there, you will lose marks. The acceleration is down, that's negative. The dy is down, that's negative. You must include those in there. If you don't do it, you'll get the right answer, but it shows me that you don't understand direction. And I need to know that you understand the direction. Put those negatives and positives. Just like this. My final velocity in the y is negative. Why do you think that is? Because it's going down. The batarang goes up, and then it comes back down. So the final y velocity is negative. Because when you take the square root, you have to do a plus or minus, and the minus just means it's going down. So based on the situation, you pick either plus or minus with that. Then we use that and solve for time. Easy equation. That's the time it takes to go downwards. Now, there is another way to solve for time. You use this dy equation, but you're going to have to use the quadratic formula. So if you're comfortable using quadratic formula, you can use this equation and solve it without needing VFY first. But you're going to use VFY anyways later, so you might as well solve it here. That's why I suggested doing it that way. So we got the time. Now let's look at how far from the base of the building is the Joker. This is our x component. This is the easy one. I've already explained this a few times. That one's very straightforward. Now we want the speed that the batarang hits the Joker's head. We have everything in our T-chart here. So all we need is to figure out what the final velocity is. Again, this is the velocity right as it hits the Joker, not after it hits the Joker. So if that's our velocity, we can break this up again, or we have it broken up into x and y. We know these. We've solved those already. We just need v and the angle. Use our Pythagoras. Solve for v. Use our tangent. Solve for theta. And we get that our impact velocity is 28.1 meters per second at 66 degrees below horizontal. That would be the speed at which the batarang hits the Joker, which is quite fast, and that would hurt. That's type 3. Those are really the main types of questions you'll given. The only other variety you could get is If the Joker decides to throw something back and he's throwing up a building, that'll be something a little bit trickier. But those are extending questions that you'll see with the worksheet. There you go. That is kinematics in 2D. That's the entire unit. Hopefully Projectiles is fun and you enjoy that. Don't forget, automatic marks. X and Y chart, do that thing, and break things up into components if you see components. But the rest of that, I'll see you in class. So here is another one. Had to do a Marvel. Well, I guess technically it wasn't Marvel at this point. Anyways, another superhero one. There were many different options I could have picked for this one, but clearly I had to pick the one where they're actually making fun of it. So here is another clip. Think about what is not gonna work out so well in this. So there you go, a superhero landing. This is common. You saw it in Iron Man, and you saw it made fun of again in Black Widow, if you saw that one. Very simple concept with this. You've got your superhero, or supervillain, I guess in this case, who is going for a landing, dropping from a high height. Yeah. That here is going to really hurt your knees. No matter what kind of superhero you are, you can assume that you've got some good gelatin going on in there, but that is going to break something. So you're bending your knee, you're trying to slow down the momentum a little bit, but that's still gonna do some damage. I guess if you have superhero healing, that would help, but yeah, that's still gonna hurt.